In this next example from Friday's notes, we're being asked to graph the piecewise function given by the definition f of x is 2x minus 1 whenever x is less than or equal to 1, and 3x plus 1 whenever x is greater than 1. So what we want to do is examine each piece by piece. That first piece, 2x minus 1. We want to graph that whenever x is less than or equal to 1. So I'm going to go ahead and kind of sketch in a little vertical line, which I'll erase later. In fact, I should probably make that a solid line so it's easier to erase. This is where our domain is splitting. Whenever x is less than or equal to 1, we want to graph the line 2x minus 1. So I'm going to go ahead and think about what that graph looks like. It's got an intercept of -1 and has a slope of 2. And so I've got 2 points, connect my line. And we want whenever x is less than or equal to 1, so I want that line on the left side of the vertical line that I drew. So whenever x is less than or equal to 1, I've got my left branch of my piecewise function, 2x minus 1. And we do want that defined whenever x is 1, because it's x less than or equal to 1. Whenever x is 1, if I plug in 1, 2 times 1 minus 1 is 1. So that point is 1, comma 1. Alright, so now we want to graph our right branch. We're going to graph the equation 3x plus 1, but we only really want to graph it for all the x values that are greater than 1. So we want to start off thinking, okay, 3x plus 1, that's got a y-intercept of 1 and a slope of 3. So y-intercept of 1 and a slope of 3, you can kind of see that that line is increasing relatively steep. And we want that graph for everything where we're to the right side of our vertical line. So I don't want to connect to the y-intercept, I only want to connect the points above that. I'm going to go ahead and erase my vertical line and my y-intercept. And we can see that if we plug in the point 1 to our second piece, 3 times 1 plus 1 is 4. So this is actually the point 1 comma 4. However, we can't have the point 1, 1 and 1, 4 for our piecewise function. That would make it not a function. 2 y values for 1 x value. So we need to choose one of the two. Taking a look at our piecewise definition, we see that when x is greater than 1, we want to graph 3x plus 1. Now, that means that we don't want it defined whenever x equals 1, just greater than 1. So at the point 1, 4, we actually want to put an open circle and then draw our line to the right. So we don't want to define it for 1, 4, but we want to have all values slightly bigger than that. So at 1.0001, this would be defined. At 1.0002, this would be defined. So we want an open circle at 1, 4, and then continuing on to the right. If we check this out, it passes the vertical line test, so it is a function.